Okay, the next video that we are learning here today is organic chemistry. So this is what we will be covering. Organic chemistry basically is the study of organic materials, things that are living, things that we use. So before we start that, we have to learn the naming 101. So if you have 1 carbon, you are known as mat. 2 carbon, at. 3 carbon, propeller, so we call it prop. 4 carbon is known as butte, not butt. 5 carbon, pen, as in pentagon. 6 carbon, as in hexagon, hex. So this is the naming for the number of carbons that are present. Okay, 2 homologous series that we want to concentrate on will be alkanes and alkenes. In the case of alkanes, they are hydrocarbons, basically hydrogen and carbon molecules that contains only single carbon bonds. Alkenes contains double carbon bonds. Because they contain single bonds, they are known as saturated. Alkenes contains double bond, therefore they are known as unsaturated. Now, hydrocarbons refers to molecules that contains only hydrogen and carbon. Since alkane molecules and alkene molecules contains only carbon and hydrogen only, both of them are known as hydrocarbons. In terms of the general formula, alkanes have CnH2n plus 2, and alkenes have CnH2n. Okay. Now let's look at two hydrocarbons, one namely butane and butene. Now butane comes from the family homologous series of alkanes, so CnH2n plus 2. Butene comes from alkene homologous series and CnH2n. So but means 4, so substitute 4 inside, and this is what you get. 4 C4H10 for butane and C4H8 for butene. Okay, this is the general formula where things are more general. Molecular formula refers to specific formula, example, how many carbons there are. So you put in the carbon, you get a molecular formula, or sometimes it's known as a chemical formula. Now there's another form that you can represent it by. It is the full structural formula. Now the full structural formula for butane is basically how you draw it is draw 4 carbons, 1, 2, 3, 4, and each carbon has 4 lines, 1, 2, 3, 4, 4 single bonds, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So the special property about alkane is all single bonds, and because they have hydrogen and carbon, they are known as hydrocarbons. And because they have single bonds, they are known as saturated hydrocarbons. In the case of butene, you have 4 carbons, 1, 2, 3, 4. Now in this case, you have a special double bond, carbon double bond. Now the double bond can be at the side or it can be at the center, and when it is at the side, you notice that this carbon here has two lines, 2 hydrogens, 1, 2, 3, 4, 4 lines, and 1, 2, 3, 4. If you put it in the center, notice 2 hydrogen is missing because 1 carbon can only have 4 lines. Okay? Okay, how do we draw? Propene. Prop means 3 carbon. Pene means it contains a double bond. So this is how I draw. 1, 2, 3. Draw the carbon first. Put in the double bond. 1 carbon then has 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. Must be connected. And this carbon here has 1, 2, 3, 4. And then what you do is you put in the H. And you get the structure of propene. Butene. But is 4. Tene is a double bond. So 1, 2, 3, 4. So I will decide to put the double bond here now. So let's look. This carbon has 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 4. Pentane. Pen is 5 carbon. Tane is all single bonds. So 5 carbons with single bonds, 2, 3, 4, 5, and 4 lines each. It's a saturated compound. Okay. I'm not going to put a H, let's not waste time. So this is the structure of pentane. Notice that there is no double bond. So these two, since they contain double bond, they are known as unsaturated hydrocarbon. And since this is all single, this is known as saturated hydrocarbon. Okay. Now let's go on to the reaction. In case of reaction, both alkanes and alkenes, they go through a process known as combustion. Combustion simply means burning an oxygen. When there is complete combustion, or when there's enough oxygen or excess oxygen present, both alkanes and alkenes will burn or combust to give you two nice products known as carbon dioxide and water. In this case, because the temperature is high enough, water doesn't exist as water, it exists as steam. So this is what you get for complete combustion in excess oxygen. But when oxygen is limited or there's not enough, alkanes and alkenes will both burn in that limited oxygen, and because you don't have enough oxygen to form CO2, what you get is CO, which is the poisonous gas, carbon, which is soot coming out, smoke, and steam. So this is not very good. Incomplete combustion is not very good because it produces smoke, soot, and carbon monoxide. Okay, complete combustion is better. Okay, let's talk about the reaction of alkane. So you know that just now that alkane goes through combustion and alkane also goes through a substitution reaction. So let's look. The substitution reaction, let's take an example, methane. When methane is exposed to chlorine gas and under the influence of UV light, ultraviolet light, what happens is one of the hydrogens here gets substituted by the chlorine. So exchange, chlorine goes in, hydrogen comes out, and that hydrogen that comes out binds with the remaining chlorine to give you hydrogen chloride gas, and you get a new structure, and this is known as chloromethane. Now, can this chloromethane, this structure here, can it undergo further substitution? Yes. So expose this to UV, more chlorine gas, then what happens? Another chlorine, hydrogen, and chlorine get substituted. It goes through substitution, and this is what you get. Now you get two chlorine, and because there's two chlorine, the name changes, and we call it dichloromethane. Okay, it goes through another substitution with more chlorine gas, and what you get is trichloromethane and hydrogen chloride gas coming out, and go through another substitution, you get tetrachloromethane. Tetra means 4. So this, when there's no longer any more hydrogen inside the original methane molecule, substitution stops and the reaction stops. So in this case, substitution can occur 4 times because there are 4 hydrogens there. So if you have something like this compound known as ethane, you can go through substitution reaction with chlorine gas, and you will get 6 HCl. If you go through it 6 times, you will need 6 Cl. Okay, because there are 6 hydrogen. Okay.